Thank you. Welcome, everyone. Thank you for joining us today at our Lunch and Learn series with the Center for Applied Artificial Intelligence. My name is Kent Malowitz. I'm the Director of Strategic Partnerships here at UMBC Training Centers and C4AI. And we appreciate you taking your time today to join us, and think it's going to be a great presentation. Just as a quick reminder, Ryan, you can forward to the next slide, please. This is our mission. We know it's lofty for a university-owned nonprofit focused on AI, but our mission is to be the world premier location for transforming society by enabling the simple and safe application of exponential technology, starting with AI. Next slide, please, Ryan. There's a good bit of content here giving it some background of who we are. We're part of UMBC Training Centers, which is a part of UMBC. And there's a few slides that go through this, but to summarize, what we do here is deliver training on artificial intelligence. We conduct research within the field of AI, which results in white papers, presentations, and new tools, such as our LLM benchmarking tool and our AI risk management framework database that we're pulling together. We test and evaluate AI tools and products, and we guide organizations through their AI adoption journey. If you can go to the next slide, please, Ryan. These are some of our components. Actually, next slide, I think I touched on some of those. Our courses and services are all listed on our website, so we encourage you to take a look at that, and we're always adding to it, modifying. On December 5th, which is going to be our next Lunch and Learn, we're going to be announcing some new membership options for the Center for Applied AI for 2025, as well as an AI learning subscription that we're pulling together, and also 2 new workshops on prompt engineering. So stay tuned on that. And with all of that, it is my pleasure to introduce our presenter today, Shane Emmons, who's the CEO and founder of Swept AI. Shane brings over 20 years of experience in the technology field, focusing on harnessing the power of AI to drive innovation. Shane's company, Swept AI, builds software that adds verifiability and explainability to agentic systems, a keystone for entrusting more of our repeatable tasks to AI. Shane's goal and his organization's goal is to unlock human ingenuity by allowing people to focus on creativity and innovation. I love that, Shane. And also, when I swiped that intro from his LinkedIn profile, I saw that he has an Emily Dickinson quote on his LinkedIn profile, and I love me some Emily Dickinson. So today, Shane's going to cover the topic, Taming AI, Managing Unexpected Model Behavior. Shane, thanks for being here, and take it away.
Of course. Excellent. Let's get the screen share going. All right. Like Kent said, today we're going to be talking about taming AI. We'll do a brief plug for Swept in that if after today's talk you're interested in learning more or you just need general help, I've got a lot of network connections. Just email me, Shane at Swept AI, and we'll jump in there. For a little bit more background on myself so that can have an idea of maybe what I know what I'm talking about. Like Ken said, I've been in the industry just over 20 years, almost 25 actually at this point. I have my bachelor's and master's in comp sci from U of M with a focus on AI. That's 20 years ago, almost to the date. I have my MBA in organizational leadership from U of M. I spent the first decade of my career in data science and data modeling in the insurance industry. Then for the last 13 years, I've been in the startup scene as a repeat CTO. I was one of the first handful of employees at a company named TeamSnap that we grew from 5 employees up to 260 before we exited in 2021 for 9 figures. And then I've been the founding CTO of a couple other companies ahead of Swept, raised quite a bit of money in the venture space. I'm also a lecturer in the master's department for comp sci out of U of M. I am the drill instructor for those who didn't have an undergrad in comp sci and really want to get a master's. I've got to drill into you in the span of 12 to 16 weeks, everything that you would have gotten an undergrad degree for comp sci. And for more recently now, I'm the founder and CEO of Swept AI, along with my co-founder, Amy Fox. So what does it mean? What are we talking about taming AI today? So before we dive into specifics, I'm going to go through 4 stories to try to ground ourselves in what we're talking about. So early on in my career, when I was doing the data science and data modeling, I took over a project that was highly manual for essentially calculating how much an insurance company wanted to pay their independent agents. This was a manual process that literally a person would spend a year crafting this extremely complex 80, 120 variable algorithm that is essentially trying to pay these agents the right amount of profit sharing money. And so the problem back then, everything was in batch. So you couldn't just put it in a batch and run it. So I ended up creating a program for it that let this person start, instead of doing it by hand, start experimenting more live so that they could do a few more test runs. They usually did 2 to 3 tests a year to figure this out. So once we had that running, we thought it would be clever to apply a genetic algorithm to start figuring out different ways to combine these variables. We had 40 years of agent data, and we had this great algorithm that we could figure it out. And so we used a genetic algorithm type of AI to figure out new ways to pay these agents. And it was great. The executives loved it because it was fitting the bell curve the way they wanted more. But then year 2, we started having very smart agents realize the flaws in these new designs, because they would sit there and had much more time than us to go through and try to figure out how to essentially exploit it. And they were able to find ways that this genetic algorithm essentially had been rewarded and take advantage of it. So that was our first, my personal first experience of an AI system that was trained one way, essentially being able to be duped in another way to have some people that maybe should have got $10,000 checks that year get $1 million checks. They did the right thing, but we had to keep training, and eventually that algorithm still runs today and makes much better decisions, but it had terrible reward systems. It really just had naive rewards. Um, I'm sure you all saw back in May when Gemini was integrated into Google, the rocks on pizza and the glue holding cheese on pizza. This is a great example, again, of non-determinism taming AI. There's nothing inherently wrong with this. I mean, we know it, but when the AI sees and is trained on data that says this, the roll of the dice occasionally puts out there. And so when we're talking about taming AI, we have this non-determinism fact. It's not that it's knowing something wrong. It's a prediction algorithm. And occasionally humans say really silly things online. It gets put into there, and occasionally that dice roll will get that. And then compound that with caching, and you get some silliness that happened. Um, what ended up having us found swept was back in 2023, the National Eating Disorder Association, quite literally overnight, because of a unionization, decided to fire their 200 essentially caregivers, volunteer caregivers, and their managers, and replace it with a chatbot called Tessa. Problem, I mean, we should all wonder overnight replacing AI like that. But the biggest problem that happened there is the bot was fine tuned to essentially try to spend as little money as possible. We're replacing people. We want to be cheaper. A lot of them were volunteers. And so the reward system there was spend the least amount of tokens. Tokens, especially 2023 on GPT-3.5, were expensive. So what it ended up doing, through no real fault of its own, it doesn't have any intelligence there. It was just following a reward system. It would propose alternative eating disorders to these teens in crisis, or ways that essentially amplified the problems they were having. Use calipers to weigh yourself consistently, the exact opposite things you need to do. And this was just the terrible type of drift that I experienced a little bit personally with other things, but here is what really hit home for us, that we need to and want to help make these systems trustworthy. And how the heck do we do that? And then the other one, it's not one that we want to dwell on, but if you've paid attention, character AI essentially had a teen commit suicide after talking to it. It did the right thing of catching the very first message where the teen said something about it, And then the prediction algorithm just kept going and fed into the kind of the boy's fears and crisis. And ultimately, he walked off and killed himself during that talk. And these are uh, terrible things that we as technologists should not be allowing to happen, and we need to learn from them. And how do we do it? So everything we're talking about right here, this is drift. It's inherent in these AI systems. It's all over the place. We discussed it a moment ago. So you have these naive reward mechanisms. They're really what I see as the primary cause of drift when we're talking about more classical machine learning models or A-star algorithms or any type of thing where we're not talking about the large language models. And this is where we're rewarding it for something we think, like keep the tokens down, and not thinking of all the consequences. As we as humans have experienced, I'm sure, plenty of times in our lives, if you're a developer, maybe you were rewarded for how many lines of code you wrote. So you wrote a heck of a lot more code. I definitely, as a developer at one point, was essentially rated on how many pull requests I did or how many commits I did. I would just make 900 commits, even if I didn't need it, because I was getting there. And so we have to think about these naive reward mechanisms when we have a not, this is not a true intelligence making decisions. It's just following a reward system, much more basic and primal. And so thinking about that. Now we have a much larger one. If you've been in data science, you've probably been dealing with non-determinism in your various models already. But with LLMs, they are built with non-determinism in mind. If you're using ChatGPT, there any of these others, there's something called temperature in there that's essentially how often is it going to pick the not top result predicted next. There's no way to know exactly inside of OpenAI what their default, if you're going through the chat GPT interface. Most estimates are having it at 0.7. This ranges from 0 to 1, and 0.7 is pretty high randomness. This is why you can ask it the exact same question and momentarily get it lower. But I think what surprises a lot of folks that we talk to when we're working with them is they'll understand this and they'll go and turn their temperature down to 0 inside of the API and still get different results. And the reality is that even inside of the LLM, if you're turning the temperature down, you're still getting some bits of non-determinism. Because again, these are prediction algorithms. They are not meant to be answer algorithms. We're not trying to produce the exact right answer because there necessarily isn't a right answer. There's a whole bunch of training data. And so there's always a little bit of non-determinism, or a lot, depending on how you're using these systems. And so really, next question is, okay, so how do I prevent this drift? What do I do to prevent it? And you don't. I think that's the one that a lot of the industry that we've seen over the last 9 to 12 months hasn't come to accept. You cannot prevent drift. If any of you were on Reddit a few weeks ago, Mark Chen, I'm not going to read his quote here, but he's the senior VP of research over at OpenAI. And he was asked, are we going to eliminate hallucinations? And he said, we're going to try to decrease them, but there's all kinds of silliness in our training data. And he called it a hard problem. And I think if you take that from the colloquial context, like, it's hard, but we can figure it out. Hard in a computer science term is a completely different definition. Not something we're going to get to. This is stuff I would talk in lectures, but we're talking about things when we're talking about P and NP complete and NP hard. NP hard problems are one that we do not know the solution to, and we also do not know if it can be calculated ever in the time we have before the heat death of the universe. So this is why quantum research goes on, because there's hoping that some of these NP complete problems we have out there will be able to be solved with a fundamentally different architecture. But I think if you're thinking, oh, the LLMs are going to remove hallucinations or drift, know that we have no idea how to do that. We'll continue to lower it. RAG and GraphRag and all these are helping start bringing grounded truths. Having Prolog be able to be used to do some type of reasoning is really helpful. But I think really sinking into the fact that this is not something that is going to change. Drift is a consequence of these reward systems and these randomness, and we have to do with it. Um, we've done a lot of research over the last year with customers of trying to figure out even where the state of the industry is, because we're seeing all this money pumped into AI, and where is it in terms of the maturity cycle of products being developed and released. And the reality is ideas and prototype make up 95% of what is being done with AI right now. And that is uh, it shouldn't be too surprising, but I think if you read the news and the hype, you're thinking there's a lot more. 4% have something in production. This is not wide, it's barely being used. This is their betas that are touching customers. Then there's about 0.9% that are starting to maintain. They've got most customers using it, it's doing something. The people at scale, they're the 0.1% of all of us in technology. And quite honestly, they're Salesforce and Microsoft pretty much. People truly doing scaling AI is at that. Uh, Perplexity, maybe, but they're mostly built on top of another person's search engine. They're not truly at that level yet. So, how do you prevent drift? You don't. You end up managing drift. So, there's really three ways or three steps to begin your journey of managing drift. The first one, we call it define and baseline. We're sitting down often with folks that are in primarily the prototype phase. They've gotten out of the idea phase and they've started to prototype something, and they'll show us a really vague, messy prompt. It's an okay start. That's how we all start, usually somewhere in the Chat GPT or Claude prompts. But what a lot of people are not thinking through is that you need to define in a more of a actual like specification, how does your AI system meant to work, and to break it down a lot more. So think about it. I'll often see people who will put a prompt and essentially ask the agent to complete 5 tasks at one time. And I sit down with them and I say, it'll be something like read this paragraph and pick out these 5 pieces of information out of it. That's summarize the prompt. And I asked them, I was like, is that how you do it? Do you read that 5 and then can answer all those 5 questions immediately? And it's no. Well, I read it and then I usually am trying to pick one out at a time. I'm like, great. What you're describing is a workflow or an assembly line. So let's extract these prompts and let's define step by step how this AI is supposed to work, because this also starts to let us extract parts of the process that we want that really are not meant for LLMs. LLMs, again, they're prediction algorithms. They're really good at things like summarizing and looking things up. They're not calculators. If we're doing a calculator thing, we need to shove that off to a programming language. If they're doing a lookup into a knowledge base, let's send that into a RAG system or a graph RAG and get some real information. LLMs are great about constructing how to think. They're not great yet. Hopefully they will be at some point, but they're not great yet at thinking. O1 is the first one that's really doing it. And what they're doing is they're having a step that goes and creates a plan and then moves that plan one by one and feeds it off to various subsystems that are not necessarily itself. The other part that it's not a surprise that people don't have it, because they think they're not going to have good examples until they reach production, but they don't have a large enough set of good golden case, base case. This is what happened, in your QA terms, when you're talking about an API or a web flow, you're probably calling it, this is our happy path. Your AI, when you're defining your schema, you need to have, in our experience, 30 to 100 happy path of this is how this thing should work. Here's the input. Here's exactly the perfect output of the system. This is going to let you start testing your system, because you have to start thinking about how you test your system in an entirely different way, which is really where we go into step 2. It's test and ultimately stress test your system. So most of us are probably thinking, depending on if you're a programming background, you've got your functional tests, you got your integration tests, you got your full stack tests, whatever. When you think about it on your AI system, you still need functional tests. You need something that can go into your system, and regardless of non-determinism, it should return the exact same thing every time. Good example was just on, there was a podcast by the changelog called Practical AI, and they were having a discussion about how you do this in the data science realm, and it really applies directly to the AI realm, hence why they were talking about it. But you have, say, something that's testing for what is the sentiment of this um, piece of text? Is this happy or sad or angry? Something very simple. And so they have one, you should have a functional test that no amount of non-determinism should change this, that just says something like, I'm happy. And that test should be able to run end to end through your system and always pump out that this sentiment was happy. The next set of tests you're going to look are your invariant tests. They would be things like, say, I love America. And so that would be a happy sentiment. And then if you say, I love Turkey, it's the exact same thing. It's just a different country. It should not change. Or, yeah, I'm applying country, but I can see, given our time of year, maybe somebody thinks it's food. But the whole point should be that as you're making these are invariant changes. There should be no difference in the output here. I love whatever should still be a happy sentiment. Then we get into variant tests where you could do things like, okay, I'm going to say, I love the United States. And then I'm going to say, I like, or I'm proud, or whatever. You're going to change the love word where you're going to have some difference. And these two, these variant and invariant tests, are the ones where you can't think that I'm going to pass 100% because of non-determinism. But what you're going to do is you're going to create this big base case. Again, I say 30 to 100 is what we've found it works best. And you're going to say, my system is never going to get worse than whatever I measure it at right now. If all 30 of these cases are supposed to return happy and 25 out of 30 do, great. That's, mathematically, whatever it is, I don't know, 75, 70-ish% success rate on my task adherence. Now I have a baseline every time I'm iterating my prompts, my agentic workflows, that it's not going to dip below. And the goal is to bring it up. But to accept non-determinism is going to say that it's never going to hit 100%. If you're hitting 100%, you likely are not stress testing your system. And so your next steps here are to, once you've got this both in your invariant and your variant tests, and you've got your baseline of 70%, what do you have to achieve to make this successful? We were working with a healthcare startup where they're providing essentially observational data for clinical studies. And so their measurement is not 100% perfect, because we would ask them, what is done today? And it's like, okay, it's a clinical researcher. Sometimes it's an intern who is taking this data and having to transcribe it into something called OMOP formats for clinical research. And so what do humans achieve? Well, humans achieve 85%. We'd really like to see 90 because we think we'd do a lot better. So we took their test. Their first test was about 72%. We helped them get that up to 85, and then we iterated again, and now we're hitting a 95 consistency. And so that's the kind of thing you want to do. And how we got them to 95, that's part of, not a secret, but it's definitely part of the harder, that's going to take far longer than this, is around synthetic interrogation and doing a lot of statistical analysis to stress test these systems, much more like if you were put on a heart monitor, like an EKG, and get on the treadmill. We're trying to stress your system in ways you can't predict. And that's where you go, again, to get to these levels of adherence that you need. You maybe have a toy, a chatbot, you're like, if it's 80%, it's great. If it's 50, it's great. It's a joke. I don't care. But you need to learn this, set your baseline, and then gradually climb up. And then inside of your integration tests, before you're deploying to production, you should be running and making sure you don't degrade.
Hey, Shane, there's a question in the chat.
Sure.
Is it the case that you need significantly more testing than traditional systems in order to deal with non-determinism?
100%. You are going to need, it's all going to depend on the capabilities. There's actually plenty of, if you've ever done research into like Q&A on like an assembly line or something of like, how much do I have to sample to figure out if this is how it's done, or into, I guess it's think about Six Sigma and that kind of thing. It's really, what's my Sigma I need to get? And yes, it's in the case of this health tech company, where traditionally they probably would have measured, we'll say, a couple hundred things. We were measuring tens of thousands of synthetic tests constantly every single time to see if we could get there. And each time they add a new, essentially, say, if statement or branch into there, it's going to exponentially explode the tests. So once you've got that and now you're ready to deploy, a lot of people think about, if you've been in SaaS or in any computer stuff for a long time, you're thinking about monitoring. AI is not something that you can simply monitor. We'd like to say the word supervise to have that really hand on it a bit more. Of monitoring is a little step back. Maybe I'm getting some alerts, but you need something that's supervising there. You may be needing to provide a gate. That's in the case of the character AI, there should have been a gate that immediately cut that off. It's not monitoring and, oh, we've got, the bot said some things or encouraged this child in an appropriate way. Developers go put it on a backlog and take care of it. No, supervise, I see it done. It's pulled out, there's connections of Health and Human Services, whatever needs to happen. Same thing needs to happen with your bot, depending on your risk level there. It's, again, if you've got a toy, be very careful of what you consider a toy. Character AI is considered a toy and it caused legitimate human harm. So think through what can happen there, and we get into supervise. And supervise is going to be your monitoring. It also can be optimization. One great thing when you have, again, plug for SWEP tools like SWEP supervising, we can start noticing patterns that can help you optimize to get better results as we're seeing how your different people interact. There's a great quick aside of an HR company that is out of Canada, and their AI performs worse in Canada than it does to the US. And we eventually figured out it's simply because their people would say please more. And because somewhere in the training and the strange nodes of the LLM, please ended up having worse responses. Maybe they were more sarcastic. Who knows? The internet's a weird place. But they would get worse results. And so what we ended up doing is adding a layer to their system that had it that would rewrite the inquiry such that it would remove those things and cause back. But there's a lot of things that can be done. So when you're supervising, it's all about monitoring, optimizing, and correcting or stopping behavior in its tracks. And so it's pretty much, I think, right on time where we were doing today. Happy to, if there's time, to take questions, but even better, contact me. I love getting on, talking with people one-on-one, seeing what we can do for you, and hopefully get you on the right way.
Yeah, so if there's any questions, feel free to post them in the chat or take yourself off mute. I learned a lot of stuff, including don't be polite, I guess, to AI, because it messes things up.
Telling the AI you will fire it or offering it a tip is a silly thing that works wonders.
Love it. And it's interesting to hear that AI is as coin operated as humans are, as far as incentive systems go and rewards, but kind of fascinating.
It's as an aside of that, a lot of AI is trained off of Reddit, and Reddit is built off of karma systems. So you are feeding exactly off of it.
Awesome. So yeah, let's give a minute. Let's see if anyone has any questions. Shane, thank you for the presentation. That was awesome.
Of course.
All right. If not, I appreciate you all being here. I'll close with just a couple of notes. Again, thank you, Shane, for your time and your expertise, sharing it with us. Just want to remind folks, I'm going to post a link here, actually. We've got a couple of, actually, if you can go to the next slide, please, Ryan. We've got a couple of upcoming lunch and learns for the end of the year. Our next one's going to be on December 5th, Unlocking Productivity with Microsoft 365 Copilot Wave 2. And we've got a couple of additional ones, and you can see for the rest of the year, we're creating our schedule for next year. Please feel free to reach out with any questions you have, or any ideas that you may have, or topics that you'd like to see us cover, and we're happy to put that into the queue. So thank you all for being here. Again, thank you, Shane, and thank you for sharing your time, everyone, and hope you have a great rest of your day. Take care.